All right, we have this code base. It's just an API. So you can see it has the init file. We have, I guess, Postgres is here, but we're not really using it. Just to make things simpler, I'm just returning a list of dictionaries, okay? Let's do that. And then we're returning this locations. This is our JSON. It has one route / locations. The .env file has specifies the location of our Flask app, and then we can call it Flask run. Remember, there are different ways of kind of booting up our app, right? You can do app.run, and then you can do debug equals true, comma, the host equals 0.0, all these zeros, right? And then the port. You can do it this way. But the other way that you can do this is, of course, just running Flask run and then passing through the arguments to specify that we're doing it in debug mode, and this is the host. Give me 1 second, and that this is the port. So I prefer to actually. What I did was I encoded it as the argument. I did it this way, just Flask run, and then you can pass through the flags. So you can see that in the Docker file, right? So in the Docker file, we're saying the host is the all zeros, the port is port 80, right? If we wanted to, we probably could even do the debug equals true thing through here, through the flags, okay? Why do it that way? Well, this way we can we don't have to change the code base to run it differently, right? We can, remember, we can always override this last command by doing, Docker run the Docker image, and then I can specify the command I want. So it just makes it a little bit more configurable. Now, right, so we have that option of encoding it or doing it as an argument. In this case, we're just doing it as an argument so that we can always change it a little bit more easily without updating the code base. The second thing is perhaps why these arguments? Why do we set the host to the 4 zeros and the port to 80? So this part is, remember, Flask will, by default, refuse requests, right? Refuse you hitting the API if it's not from your local host by default. That's to protect, right? That's for security reasons. Is to make sure that you're only giving access to other machines if you want to, right? So this allows that. The same way that with our EC2 machines, we do the same type of thing, right? If we want to make it publicly available, we do the 4 zeros. The port 80 is because, remember, we're going to be deploying this to an EC2, and by default, and so we want to make this productionized, and by default, your browser makes a request on port 80. So if it's making a request to port 80, we want to make sure Flask is responding to requests on that port, right? So that actually hits your API. Okay, so that's that part. There's not too much there, right? So you can see what's going on. We're starting off with a Python image. We're creating this app directory. We're copying the code base, right? We're copying the contents here over to my image. We're installing a couple of libraries, Postgres, just some required libraries. And then finally, we're installing what's in the requirements, which is just Flask and Python.env and the Postgres, Python. Normally, this is scicop G2 binary, but we're not even using Postgres in this case, so it's not a big deal. All right. At this point, we could just build the image, Docker build -t, the name of the image that we want. So let's say it's Foursquare restaurants, and then the build context, right, as dot. There's going to be an issue with this. This is fine for locally, but the next step after we build this, so we can build it, this will work. But then the next step for us is actually we're going to want to push this up to something called Docker Hub. Let me show you what that is. So Docker Hub is like GitHub, but instead of pushing your code there, you push images there. So you can see I have these different repositories here, right? Like they're called repositories, the same thing, right? And these are images. So when you did like Docker pull down an image, we use these like kind of standard images, but you can also do that for your own image. So you can see, right? Like you can push to, an image up to Docker Hub, and you can also pull down the image from Docker Hub, right? And this is like the address to pull it down. So the issue that we're going to have with this naming, I guess the issue we're going to have if we just call it Foursquare Restaurants is that you can't push. The next step is going to be Docker push Foursquare Restaurants, and you can't do that because it doesn't know whose repository you want to push this to. It has to be like my username, which happens to be JEK2141, right? That's just my username. Okay, so it has to be your username / restaurants. So the first step is we actually have to call our image. We have to make sure our image name starts with your username / and then the image name. Does that make sense? So what we have to do, it's not so hard. All I have to do is, do I not have it? It's all right. We'll do Docker build -t JK2141 Foursquare Restaurants dot. That's it. So you just have to make sure you prepend it with your username. If you don't have a Docker Hub account, that's fine. You just go here, and then this thing will. If you're not signed in to your Docker desktop, it will have like a link for you to. It will say like create account or sign in, and then you can create an account there. Or the other thing you can do is and this is in the reading, you can just go to hub.docker and then click on sign up and create an account. All right, so we'll build this. It took a second because we already basically built it. Then the next thing for me to do is do Docker push this thing, and this will push it up to Docker Hub. All right, so you can see it's pushing it up there. Okay, why is this useful? Because then we're going to create an EC2 machine and clone it down, right? Pull it down to the EC2 machine. All right. So let's go through that. Let's just make sure we remember. Yeah, Conwell.
A quick question regarding pushing this image and images in general. When we say we are pushing this image to Docker Hub, I'm trying to understand, are we actually pushing all the installations which happen in the Docker file as well? Like, what exactly it means? Why we can't just push the Docker file, definitely name it something versus pushing an images? I'm trying to understand. Like, it's anyways going to install all those packages in our own Docker system, in the Docker file, whatever we mentioned in the Docker file. So I'm trying to understand what exactly will that hub contain when we say we push an image.
Well, this is already, I guess to me it leaves less up to chance. Like if you think about the steps involved to, in our Docker file, it's like copying, right, like the local files. So if we built the image onto our EC2, we would have to make sure that we also have like the correct code base and that we then like build it, properly once there. So like here, we're basically doing all those steps, like we're packaging everything up, and we don't have to leave anything up to chance. You just kind of like pull down the software and only this last line will be run. So it's like all the setup is basically completed, like we're like securing as much as possible, I guess, in my view, by packaging it up. Like, could you do this? Probably, right? I would have to have that extra step. I would have to like clone down the repo there. The other thing is we'd want to make sure that it's not just, right? We'd want to make sure that like there's consistency between my development environment and production. So we're gonna want to like package this thing up so that anyone can use this pretty easily anyway. It's just like one last step that they'll have to do to like build the image and make sure they don't have
Yeah,
any junk.
that's not what I'm confused about, though. I understand your point about having a consistent environment and thus pushing it. My question, though, regarding it is, uh, what is the meaning of pushing an image? Well, like, if we had a mechanism of just pushing the Docker file, because that's eventually what is going to be used for
Oh,
setting
I
up this
see.
environment and then running the last CMD is my
So you're saying
question
like it
here.
saves space, perhaps, by pushing the image? Is that the kind of what you're saying? So just like push the instructions instead? I think that would
Yeah, the
also.
Docker file eventually. Like, what is the
Yeah,
meaning of pushing the whole image, which doesn't make quite sense to me as of now. I can't
I get your point. Like
quite
there's
understand.
this kind of space issue potentially, but I don't think. I think like the reason why you do that though is probably just in case, just because like, well, let's say these libraries are updated, and so when you pull it down, you pull down the Docker file, and maybe it's automatically installed, but then these things changed, right? Like then there could be again some sort of inconsistency. So here we're not even really reinstalling this stuff. It's just this software is up there and we're like pulling it down. We're pulling down those layers. Yeah. I mean I could see your point is like, well, we can save space, but I guess here we're trading consistency for space.
I see. Thank you.
Yeah, Kyle asked, are we going to get into GitHub Actions? Probably. I don't know if we'll get like we'll probably at least cover some GitHub Actions eventually. I'm not sure exactly how far along we'll get with that, but we probably will get to some of it. We'll see how much time we have in the course. Okay, cool. So what did we do so far? We built our image, and then we pushed up to Docker Hub, and then you can confirm by like going here, right? And you can see this was last push 3 minutes ago, and it's up there. What's the next thing? Now we have to go to AWS, sign into the console. Oh, look how easy that was. Okay, click on EC2. You can see I already have an instance running. We can destroy this. I should save some money, right? Okay, let's launch a new image. We can call this, I think you should probably get in the habit of like giving your EC2 instance a name, just so it's easy to keep track of it. So we can call this my Foursquare backend, right? Remember it's like going to, like a computer store or whatever, Best Buy. You walk in, you decide, okay, what kind of, do you want Mac or PC? We want this AWS Linux. That's the software. Then there's the, hardware, right? Here it is. Here, 1 GB of memory, one CPU. That's good. For the key pair, I can use one that I already have. We've already created the key pair. Like I already have this example PEM file on my computer, and I can just associate it with this machine. And then for the security group, I can set up two. So one is SSH traffic. So this is for me to like bash in, right, to SSH into the machine. And then the other one is HTTP. This is for when people actually make requests to my website. We set up some, volume storage stuff. That's pretty good. And then we're gonna have to wait. Let's click on instances. This is why you do this, right? This is the one that I want because we just named it. And then I'm just gonna wait until it gets. I'm waiting for this connect thing. You can see it's pending. Eventually what I'll have to do is, so I can start doing it, is go to this /.ssh folder, right? And that's where my PEM files are, including that example.pem. And then it's something like ssh-i example PEM, and now we can connect. We'll just copy it. ssh-i example PEM. This is the user. This is the domain name. Okay. Say yes. And we are going. All right, what's next? So now we're in our EC2 machine. We're going to have to actually like install Docker, right, on the Docker software on this fresh EC2 machine. So to do that, we already, because like Linux has this package manager called Yum there, like already installed for us, we can do, sudo yum update -y. This is just to make sure like we have the latest version of Yum. Normally it says this, there's nothing to do. Then we can do sudo yum install. I forget what the -y does. I'm not sure. Someone can Google it. So we're installing Docker itself. And then the next thing we'll have to do is actually like boot up Docker, right? Like make sure it's running on our machine. Okay, so that's done. So we'll do sudo, this is it. System ctl start Docker. So systemctl, which I spelled wrong, is software on Linux machines that allows you to start and stop services, right? And like manage them. So here we're just going to use systemctl, the start command, and then the service or the software we want to start. So that's Docker. And now Docker should be running. Like you could probably look at it, maybe not so easily, and do like pipe grep. Docker, will that work? Oh, and there it is. This is it. Okay, so this is running. What's next? Oh, what I would do next is like also just like an easy way to confirm is to do like sudo docker ps. Make sure you're getting something back here, right? Here we're listing all the containers. There are none. What's next? Probably sudo docker pull down our image from Docker Hub. So JK, let's click on it. This guy. JK2141, restaurants. It's pulling. Okay, beautiful. What's next? We have to do sudo for every time we type Docker. So sudo docker image ls. Let's run it. Ugh, that wasn't on purpose. Sudo docker run -p. We want to map the containers port 80 to the image to the EC2 instances port 80, right? And then I want the name of the image I want to run. So that's this guy. Oh no. Miles probably knows how to. What do I do? Thanks.
It depends what's in your image declaration. It's a versioning problem.
Linux AMD version 3 and no specific format. The requested images platform does not match the detected host platform, which is AMD 64. So does that mean I have to?
Where's Julia? Julia had to navigate this recently.
Yeah, let's put everyone on the spot. Just kidding. Yeah.
I think you mapped multiple architectures somehow.
Yeah, are you on M1 Mac?
Yeah, I'm on an M1 Mac, and I guess
Yeah.
this is
The
saying.
V8 is M2.
I think it's saying the host platform is AMD 64. So all right, so we should can't we
You
specify?
just need to downgrade, downspec some versions.
But I think I can't. Can I specify the platform with an environmental variable? Isn't that what we did?
Yeah, you can export Docker default platform, but if you have a version platform mismatch, that won't help.
Oh really? Oh, because I have to
Yeah,
do it
it
when I
depends.
build it. Is that what you're saying?
Because it's looking for a firmware version, and if it's expecting V8, which is very new, then it won't be compatible with V3. But you can try the export first.
Yeah, it probably won't work.
You could also try to rebuild it with Julia's flag.
Yeah,
She
that's what I
pasted
think
in
I'm
the
gonna
chat.
do. So let's
You can also, I think like with the, from Python, if you put the flag, let me double check my code, 1 second.
Okay.
That platform will do the same thing as your export Docker default platform variables.
But so the issue, just so we get it, the issue for everyone, right, is that like the chip that's being used, I think when I build on my machine, my laptop, is different from what's on Amazon's, and the software it probably detected mine. Actually, it could be that it probably detected like what mine was on my laptop and built a different version of the software than is required for the for Amazon's machine. All right, so now what we're thinking is like we could rebuild the image on Amazon's machine. The way to do this, right, is we can go to GitHub, maybe just clone it down and rebuild it. Let's just do that. I think I can do this. I did just try this, and I probably have to install yum install git client. I may have to yum install git. All right, we'll see if this works. Oh, sudo. Man, we were flying. Okay, let's see if this now works. Okay, that worked. That's easy enough. So I just cloned down Docker AWS. We have this Foursquare API. And now I'll do docker build -t. I mean, we could eventually push this up. So I'll do JDK 2141. Oh, and I should use the flag -- platform. So we'll tag it. JDK2, let's say Foursquare updated backend. Or I could change the version too by putting something like this, like v2. But we'll just do that. And then we'll do this -- platform. Is it 1 hyphen or 2? Do you know? It's 2 hyphens. Is that right? I'll just type it out. 2 hyphens, and then we need the dot at the end. Sudo. Right, so I keep getting these permission denied errors. And for that I should do sudo. All right, so we are rebuilding it. And then we'll see. I mean, the other thing we could have done was probably could have built it locally, on my laptop, push with this flag, and then pushed it up.
Mm-hmm.
We'll see if this works. And so maybe that would have been smart, and we could have just had a different tag, based on if we wanted like AMD64 or the other one. Okay, so now we can do sudo docker image ls. This is the one I just built. And now I'll do sudo docker run -p 80 to 80 this guy. Okay, that seems pretty good. Now what? Now let's go. So one thing, notice it says running on all addresses, has the 4 zeros. That's good, right? Because it means it's allowing outside machines to go there. And then we should go back to my instance and go to the DNS. So this is, right, the domain name that it gives us. And basically what we want is just to do http:// see if anything, this is beautiful, right? Because this is what we see when we see Flask is running. So now we just have to go to the right, route, which is, I must have put it, is it not locations? It is called locations. So it's http:// Oh, there it goes, right? And this is it working and deployed. Things that you should check for. So just to recap, kind of like that snag that we ran into was Docker will look, by default for, I have a Mac M1, and based on the chip, it can build a different version of the software. So it seemed like there was a difference between what my laptop was running and what the EC2 instance was running. So for us to fix it, what we did was we basically read the error message, right? Because when I tried to do Docker run, I did this, Docker run the original image, it gave me a pretty good error message at least, saying that the images platform, right, this is how I built it, ARM64, did not match the host platform, AMD64. So what we decided to do was rebuild the image and specified that we wanted the platform to be Linux AMD64. And what this will do is make sure that the software that's being built, like the versions of the software, is compatible with this Linux AMD 64 chip, I think. All right. And then the next step, once we had this built, then the next step was kind of the same thing as always. We basically just did sudo docker image ls, list it, and then we can do sudo docker run. We just have to map the ports 80 to 80 and then specify the image name. And now this is working, right? And then the only thing that can go wrong, well, I shouldn't say that. One thing to check for though is click on security, make sure these rules are right. So you basically want to look for two rules. One is that port 80 is exposed, right? You see the all zeros. The other is that port 22 is exposed. Okay, so you see the all zeros there. Cool. Questions about that? Is there anything special about port 80? Yes. When you go to a website, what you're doing is you're going to port 80. I guess I'm lying. But that's what you're doing. You're going, I forget, I don't know, maybe they changed it for Google. But so notice that like here, we did not have to specify a port. Like we don't have to do port 80. By default, you see that? By default, it's making the request to port 80. This is just what browsers are doing for us. If we specify that it was like port, I'll plug this in, that is port 3000, then we would have to specify it, right? And it would, if we didn't put in the port 3000, it would break. So when you're deploying a website for the internet, you set it up for port 80, typically. Okay. Oh, that's the other thing. Yeah, good call, Narapati. I'm doing HTTP access, HTTP, not HTTPS. So if you do HTTPS, it's not going to work, right? Because for that, you need to like get a certificate for secure access, which just takes time and maybe some money. So we're not doing that. So you have to just do HTTP. Make sure to change that : // and then you're pretty good. All right, and this domain name you just get by clicking on your instance and then looking for the DNS. That's interesting. The platform flag could be added to the from statement of the Docker file if you know that it's So some of the, you're right. That's probably true. Like some of these have different versions, probably like dependent on it, dependent on what kind of system you're using. So I guess you can specify it here somehow. Can you do it like that?
I think it goes before.
Before, that makes sense.
Python, yeah. At least that's how I've run it.
Yeah. So there's that, right? And that way you can use the same right version. The way that we did it was put in the Docker build. So we did it by doing something like Docker build -- platform Linux, and I can Slack this out. -- platform Linux AMD 64 -t the name and then the dot. All right. So you'll just want to make sure that, right, that obviously you use your username, not mine. Cool. All right, and then when you're done, let's actually do it this time. Shut up. Terminate your instance, right? Save some money. Actually, so just click on instance state and then terminate, and we can terminate. Cool. All right, so I'll let you go through that. Worth point in the reading was, okay, so like we're gonna want to like change our code, but remember the idea is like that we want the environment that we're working in to be as consistent as possible as to production environment. So when we change our code, like how are we gonna do that inside of a Docker container? All right, that's the idea. Let's do Docker PS. Sorry, I just have to stop this. Docker stop. And now this should stop. Eventually. Okay, cool. So this is, we can start here. So if I do Docker run, we'll map the ports. I will actually delete this for now so you can see what happens. So we'll map the port, right? Port 80 to 80. I'm on my laptop, right? I'm not on the EC2, right? Because I'm going to code, make changes on my laptop. Then when everything's good, you know, and like after 1,000 people sign off on it, then it'll be moved to production. So we'll code. What we're doing is we're basically saying when we boot up our container, like this is the key part, we're going to bind mount, right? So in my container, we have our code, right? But what I'm saying is instead of look at the code in the container and that we moved in the image, look at the code, point to the code on my computer. That way on my laptop. That way I can change this code on my laptop, and this is the only part that will, this code will basically live inside of the Docker container, right? It'll have that portal into the Docker container. So that's what we're doing. We're booting up my Docker image, this 4-square backend, mapping the ports, and also doing the bind mount. Okay? If I press return here, you'll see that it's giving me this thing about the Linux AMD, but I can, let's stop it, because I just discovered this. Docker stop. What I can do is use that same flag that Julia mentioned when I boot up the container. Even without rebuilding, it looks like I can use that same flag. Maybe it doesn't always work, but in this case, it seems like it did. So this time I'll just add in that flag of because right there's this difference, I guess. Anyway, so now it's working. I'm specifying the platform should be Linux AMD 64, and it's happy. If I go to here, that's not what I wanted. I don't know what I have running there. Localhost 80/locations. This looks good. Okay? One thing to note, let's take a look at this. I should be able to change this, right? And then if I refresh, I want to see the changes here, right? But I currently don't. Numero uno dos tres, but it's like not showing up here. So let's figure out why. What we can do is Docker PS. We're going to sh into our container. So we can do Docker exec -it here, and then sh into the container. And basically, let's see if we're at least getting the changes in the code. So we can cat the init.py file. And notice, right, here we are getting those changes. So as I made changes here, I don't even know how to spell it, Quattro, like that. We are getting them in my container, all right? Which makes sense. It is just a portal, right? It's not looking at anything in the container. It's saying when you get to here, to this folder, source app, instead look at the present working directory in my computer, right? And the reason for that is this line right here, -v, anything here, really look at the API folder on my laptop. All right, So then why are we not actually, why are we seeing the changes in the code, you know, here, but not seeing them if I refresh? Okay, and the reason why is because remember Flask has this issue where it's not going to live update for you just by default. So what we could do is we could, you know, Docker, we can just like from here ps aux and shut this down, right? Like, you know, kill this and then reboot it. Or the other option we can do is, you know, there's this debug equals true thing, app.run debug equals true. That will get the live updates. But really what we'll do instead is when we run this, we can just add that flag of whatever, I forget what exactly the flag is, something like development equals true or Flask development equals true. Here it goes, Flask env equals development. That's it. So basically we're just going to set an environmental variable. We can do it this way too, probably. But export Flask env equals development. But we should just do that when we boot up our Docker container. So let's do Docker ps. We can close this, Docker stop this, and then we can wait, I suppose. Okay, cool. And now we'll just add in that flag of -e. The -e is for environmental variables, right? That's and then we'll do Flask env equals development. Let me see, there's a question. Oh, you can stick, yeah, the thing is, you can place this in the Docker file too. So why do I not put this in the Docker file? It's because, well, in production, I don't want to put in the development flag. You know, if we use this on the EC2 machine, right? So we could do it here, but I don't want to because I don't want to have that development mode in production when we use the same image. So we'll just do it locally, right? And we can do this. And that looks, eventually that boots up. This looks pretty good. Now, if we go here, the localhost, locations, that's there. And now we'll make an update. And let's change it back to Uno. Refresh. And it changes. Okay? So there's two components to this. The first one is make sure the code, right, is actually pointing to the code that it's reading from, the code base in my container is pointing to my laptop, right? So that's this bind mount. The second thing is have Flask live update. So that to do that, we're just setting this environmental variable of development. How do I know that? I asked ChatGPT. How do you set environmental variable, or can I run Flask, the Flask command, such that blah blah, such that it gets live updates. Okay. All right. The next part, kind of what I was explaining was, so you can kind of code along here, right? And then probably what you want to do is be on a separate branch, be on your feature branch, make your change, git add all, git commit -m, updated feature, push origin feature branch, so push to GitHub. And then what you'd want to do is, and this, I'm sorry, this did not work. I didn't think of getting this to work. Instead of copying your code base, right, you can just git clone from main, right? Like run git clone, or git pull, I should say. That branch, the main branch, the repo. All right. The issue that you'll run into with this is Docker by default tries to save you time and space by using the Docker cache, remember, right? If there's no changes to your Docker file, it's gonna just use what it already has. It's not gonna rebuild this. So what you need to do is you need to specify that no cache when you're building it. I put it down here. You have to basically say hey, rebuild it from scratch. I don't care, So that's what we're doing here. The other thing is, though, when you push up to Docker Hub and then you re-pull it down, it's going to think, I already have this image. I don't need to pull it down again. So what you should do is also give it a set upgrade, bump up the version, right? And that should work, right? So when you build it, right? So basically, you'll make your change, you'll push up the feature to the feature branch. Someone will merge down to master, or merge it over to the main branch. Then, in the Docker file, if we build it with no cache, it will clone it down, right? Pull the updated change on the master branch and run it, and you can confirm it works, everything looks good. But also then your EC2, if you so you'll build it, you'll bump up the version, then you'll push that version, that upgraded version, to Docker Hub, and then on the EC2 machine, you'll log in there, SSH into the EC2, and pull down that new version, and just do Docker, same command, Docker run, whatever, So that's what you can do. There might be better workflows, but that's pretty good. One other thing I should mention, I'm pretty sure on VS Code there is, I think there might be some extension where it will automatically do this bind mounting for you. I'm not sure, but I think there's something like that. So you can just Google that and see. All right, but this is I just wanted to cover how you can develop inside, write code inside of a Docker container and get everything working. Okay, questions about this lesson or anything we covered? All right. Next thing is scraping. There's not too much to say about scraping other than to go through the reading. I think that you can, more or less understand this. Basically, the workflow is we make a request just the same way that we made a request, for an API. Except, when we get back this response, so here we're going to the Wikipedia page, right, for the Beatles. Okay. And, sorry. This time, when you get back the response, right, it says 200. There's no JSON, right? Normally we do .json. Here you just do .text. And there's no parentheses. I don't know why. There just isn't. And this gives you back, oh no. Oh, it's probably fine. It's just getting cut off. Look, beautiful text. So this we can call my HTML text. And this is a string. Okay, if you look at the type, this is just a string. And then we can use the beautiful soup library. And basically what we'll do is you turn this string into a beautiful soup object that is easier to parse through, right? Once we have this soup object, this contains all of my HTML, right? Because we're passing all of the HTML into beautiful soup. And now this looks basically the same, but the difference, right, it's just as messy, but the difference is now you get some methods, okay? This was a bit much. So you can do soup.findAll and pass through the name of the tags, right? If I want to find all the H1 tags, here's all the H1 tags on the page, okay? And then from there, you can get probably get the text from this. I'm not sure. Oops. The problem is this is a list, so I can go to the first one or the second one, right? So I can go to this is a list, go to the second element, sorry, and now do .text, right? Or I could have looped through it and gotten the text from each one of those elements, right? So this is a more, if you want to be more specific with the selector, right? Here I'm using the attribute of, the class attribute and say only select it where if the class attribute matches this, right? And you can do that for various attributes, right? And I think you just use this key value pair. One thing, by the way, you should know is that if you like ChatGPT is pretty good at scraping and things like this. So if you like inspect or do like view page source and probably just like select the right kind of data, like let's see, like George Harrison, not sure. You can probably ask ChatGPT to write the beautiful soup code to pull out all the members of the Beatles or something like that, and it will probably do a pretty good job. Maybe you have to modify it. Maybe you say pull out all the list elements, but you can give it some of your code, some of the HTML, and ask ChatGPT to do that for you. But the reading shows you how to go through and use Beautiful Soup. The main thing is actually using the inspector lots of times, right? Because what you want to do in terms of a workflow is basically be like, all right, I want this kind of information. Let's get pretty close to it by, right, I'm doing this 2-finger click, getting to the right box, and then if I want to select this box, right, now it's like, give me the div with this class of info box caption, and then see if that works. So it'll be like a div of class info box caption, and that looks like what I want, right? And then from there, there's different methods for like finding, all the A tags in here, right? You can kind of chain onto this. Okay, so what you could do, for instance, let me just show you. We can like get this one, and now from here I can say like dot. I think I can do dot find all from here, and say, okay, in this info box caption, find for me all of the A tags. Right, and now we have a list of the A tags, and then I can say, okay, here are the band member links, right, and do something. Okay, for band member link in band member links, right, give me back the band member link dot, you can say title or text, dot text, right, and that's spitting it out. All right. So that's kind of like the main thing is you find the element you want, you can select it, right? If we could have just done find instead of find all, and then from there you can dig deeper with another find all inside of that parent element, right? So that it's pretty useful. Okay, so this seems like it takes you through essentially just that. All right, so this is the Beautiful Soup lesson. The next thing is then Selenium. Selenium is very useful when there's JavaScript on the page. Okay, it's useful for a couple things. One, there can be JavaScript on the page. Two, it can help avoid some blockers, right? Like sometimes websites are oftentimes trying to stop you from scraping their page. Selenium sometimes can be a better option than this. You can see the WebDriver Firefox means, oh, I must not have installed it or something. The WebDriver Firefox means that it will use Firefox to like open up the web page, and you'll see it if you install it. It's actually like a fun little thing, and it will navigate just like your mouse can navigate. So you can tell it to like find an element and then click on it and things like that in Selenium. We won't, so this goes through some of it, I guess. It probably does tell you how to click on it, digging deeper, find by certain things. Okay, so yeah, you can see what this is doing here. Maybe I can even show you this. So we go to the page for New York City apartments, right? So the get makes a request to that page. Then we find the input box, and the send keys means like fill out the form, And then finally, we look for the search button, and we do .click to actually click on it. Let me see if we can get this working. I'm not sure. I wasn't. All right. Okay, so we're importing the WebDriver. We're importing like this keys thing so we can fill some stuff out. The WebDriver.Firefox. This means like use, Firefox WebDriver. So like basically open up Firefox. Let's do Python 3 index.py. Oh, and I need to pip3 install Selenium. If you believe this is a mistake, try brew install. It doesn't like that it's an externally managed environment. I don't know if it broke. I think seems like maybe it did. So Python 3 -m venv source venv bin activate, and let's see if we can install Selenium now. Okay, that's doing better. So I basically just created an environment, and now we will run index.py. And this should actually like open up Firefox for me. If I have it installed, you will need Firefox downloaded on your computer. It's possible I don't have it on my computer. I do have Chrome on my computer, so I can change it if this doesn't pop up. Let me go to the lab. Oh, hold on. There it goes. Damn. There it goes. All right, so it's opening up. Is it actually Craigslist, APA? One thing that's nice that you can do with the code is you can put a breakpoint, just like with anything else. Okay, so like, you can put a breakpoint here and make sure that each one of these lines work. So you can see it's breaking. Apparently one of these methods changed, like the find elements by class names. So this broke, but you get the idea, I hope, that you can like use these different methods. I don't want to go too deeply, or like spend too much time onto this, because the lab shows you how to like, one, I think you can just Google this and figure this out, and then two, the lab shows you kind of like how we'll be using Selenium, which is essentially, and like scrapers in general, which is essentially like we can basically like just get the text from each one of these pages and not worry too much. Normally when you write scrapers, the old way of doing it is that you would, be like, all right, I want to identify exactly where's the title and find the element that shows me, okay, here's the title, and then that means I need to like make sure I write a very specific selector to pull out the title. And then go to the next thing and make sure I pull out the thing that lists when was this listed, and that's how I'll figure out like, here's the title, and here's when it was listed, and here's how many bedrooms, and here's the neighborhood. That's one way of doing it. However, in the age of ChatGPT, what we can do is just like take each one of these boxes and pull out all the text, and then just feed the text to ChatGPT and ask it to tell me, what's the listing title, when was it listed, how many bedrooms, right? And format that for me in JSON. The benefit of that is that as Craigslist, maybe not Craigslist, but many websites update their website and change the HTML, my scraper won't break, right? Because I'm just asking for like general information. I'm not expecting that every little HTML element stays consistent. I'm just asking more general things, and then telling ChatGPT to figure out the text. So that's what the lab will have you do, is like pull out this element, pull out all the text, and then say if you pull down all this element, maybe summarize this for me, and pull out the price and information from just by giving giving text to the API and asking back, how much did it cost? Are pets okay? Et cetera, et cetera. All right. It will. Sorry if this was a little confusing. That process will make more sense as you go through the lab. And I did a lot. I just kind of show you how to do that in the lab. I don't know. Any general questions about? Sorry that I couldn't get. Well, we'd have to update these methods, but I don't know. Questions about Beautiful Soup or Selenium? Sure.
Jeff, have you played with Olama at all, or any local models? I know Olama has like a Python package now, and I'm wondering if it made any kind of sense to like bake in some kind of local model into a scraper.
So, yeah, Kyle's talking about like a like. You can, instead of using, OpenAI's model as an API, you can like download an entire LLM model onto your computer. The main benefit of doing something like that is there's two benefits. One is for fine tuning the data, right? And then two is like if there are privacy concerns of sending text, to a third party system. Right, like say it's medical information. However, like I think some of our internship partners says there are options on OpenAI that basically account for that. That like where it won't save anything, record any of your data. So the only reason for using like a local LLM model would be for fine tuning, meaning like customizing the model so that it's just trained on your data set, and so then can give better responses. But that's challenging, and you can get very far without doing that. So I have not gone through that. Other questions about this? All right, so I'll let you do the reading. We'll finish up here, obviously, after the reading on Selenium and